Going to demonstrate that linear function. We've got a spring hanging from some suspending apparatus and a washer on the spring, and I know that the bottom of the spring comes to right there. If I add a washer, pulls the spring down so that now the spring is here. If I add another washer, unsurprisingly, the spring extends a little more to here. Add another washer, spring extends somewhat further. And if I add another washer, the spring extends some more. Now if I just take this down, okay, if I measure the positions of that spring, let's say, actually, we'll measure it in this direction. And actually I'm measuring the position of the end of the spring below the point at which the whole thing was suspended. And now that doesn't give us the length of the spring. We didn't even measure the length of the spring. But I see that my measurement here is 56.5 centimeters. Here it's 61 centimeters. Here it appears to be 66.5 centimeters. Here it looks like we're at 72.5 centimeters. And here we appear to be at 78.5 centimeters. Okay? Now, is the length of the spring a linear function of how much weight is pulling it down? Okay, well, we have one washer here, 2, 3, 4, and 5 washers respectively. Here, here, and here. Is that a linear function? Okay, well, before I go on, you should determine whether the length of the spring is a linear function of the number of washers. You should do whatever is necessary to do that. Now, you might or might not actually do that, but you'll learn more if you will. And the video will continue in just a minute. Here I've made a table of our information. Y really isn't the length of the spring, but we can treat it as if it was. Not that important for illustration. If you're trying to do physics with it, you better be careful. Okay, so what we want to do is we're going to look at delta Y, delta X, and delta Y divided by delta X. Okay, in this case, delta Y is what? That's 4.5 centimeters. And delta X is, of course, one washer. And abbreviate washer with W, so delta Y over delta X would be 4.5 centimeters per washer. This picture is just here to keep the camera in focus. When there isn't much on the board, we don't need it anymore. Okay, so we get this result. Here we have a delta X of, from 61, or delta y from 61 to 66.5, that's 5.5 centimeters. Delta x is 1 washer, so we have 5.5 centimeters per washer as the average rate of change, or the slope, between these data points. Here it looks like we have a delta y of 6 centimeters. Delta x is still 1 washer, so now we got 6 centimeters per washer. And finally down here, between 72.5 and 78.5, the rise, delta y, is again 6 centimeters with 1 washer. So we get 6 centimeters per washer. We see that delta y over delta x is not constant. The average rate, which is equal to the slope, is not equal to some constant number. So the graph is not linear.